Welcome to VW 4.2. Today we're going to be talking about operations on functions. So our first example here, I give you two functions, f and g, and a whole bunch of operations. And notice how it also says to determine the domain. So we'll do that at the end. Don't worry about that too much. These are pretty intuitive. If it says f plus g, you literally just take f, 1 over x plus 2, and add it to the g function. From here, this is basic algebra 1. Let's get your common denominator. So multiply this one by x minus 1. So you have x minus 1. Multiply this one by x plus 2. That's x squared plus 2x. And that's being divided by your common denominator, which is x plus 2 over x minus 1. Now, in case you're not sure how I did that, this is all I did. Multiply that one by x plus 2. Multiply this one by x minus 1. Now I keep going. This is x squared plus 3x minus 1. And the bottom, you can leave it factored. If you want to, you can multiply it, but if you want to leave it factored, that's perfectly fine. That's your final answer. Now for the domain's pretty interesting. If you look at this last thing, we can clearly see what x can't be. We can see that x cannot be negative 2 and 1. And that's because that would make the bottom 0. But what's tricky about these is you also have to make sure the beginning of the problem fits this. So for example, look at the very beginning, and I can see that x can't be negative 2 and 1. So we just want to make sure that that gets accounted for here. So I know that might seem weird because right now nothing changed, but later on you'll see what I mean. So I'm going to put a note at the bottom for you. And again, this will make more sense in a bit. For domain, check your starting and ending function. Let's go to B. B simply subtract. So I'll put a bar here. 1 over x plus 2 minus x over x minus 1. I'll do the same thing I did in A. So hopefully you can do this part in your head. X minus 1 minus x times x plus 2. That's all over your common denominator. From here we can see that this would be x minus 1 minus x squared minus 2x. All over your common denominator. And we put it together. That's negative x squared minus x minus 1 all over x plus 2, x minus 1. Now for your domain, notice how the beginning and the end, they pretty much match in terms of the restriction. So I'm just going to grab this thing over here, copy that. Now for the next problem, times. So all we're going to do is multiply them. So this is actually an easy one. 1 over x plus 2 times x over x minus 1. That's just x over x plus 2, x minus 1. That's a great one. For domain, notice how, again, the restrictions haven't really changed. So we'll just paste what we did earlier. Now here's the last part. Division. So for division, I recommend you write it horizontally because it'll be more apparent what you should do. So 1 over x plus 2 divided by x over x minus 1. Now it should be clear. You multiply by the reciprocal, like that. And there's our answer. X minus 1 over x and x plus 2. Now here's where the domain is tricky, and this is where that note I gave you earlier really kicks in. If you just look at the ending, you're not going to get all the answers. Because if I look at the end, I can see that x cannot be 0 and negative 2. However, look at the beginning. I can clearly see that right here, you also can't plug in 1 because then you divide by 0. which means you have to account for that as well. So those are the domain values for that. Here's the last type of example we're going to do. Finding the difference quotient. So all of you highlight this. The difference quotient is this thing right here, and that will always be given, so no need to memorize that. As far as what it does, this is going to lead into calculus later. So right now in Algebra 2, we kind of just practice the skills, meaning that you can do this operation. You're not really going to know exactly what it means until later. For now, you're just going to get the skills. And what you're going to do is understand the goal. The goal is going to be to eliminate two things. This f of x and this h. So as we're working through this, we're trying to get rid of those two pieces. So to do this, there are two steps. Step one, we got to find f of x plus h. Now this is a little bit algebra intensive, so basically we're going to plug in x plus h everywhere we see an x. So 2 x plus h squared minus 3 x plus h. We're going to simplify that. That's 2 x squared plus 2 xh plus h squared minus 3x minus 3h. Multiply that in. We have that. Step 2 is you plug it in, meaning we plug it in to this thing right here. Because what we just found, this piece, this is f of x plus h. That's why we found it. So I can write 2x squared plus 4xh plus 2h squared minus 3x minus 3h. We're going to minus, because that's what it says, minus. And notice how it says f of x. So you're going to minus the quantity of your original function. And then we divide it by h. So remember the goal. We're trying to eliminate f of x and that h. So if we did it right, a bunch of stuff should cancel out. We distribute that negative. Let's take a look. Yep, the 2x squared cancels, the 3x cancels, and because those canceled, let's look at what's left. 4xh plus 2h squared minus 3h all over h. Now we can reduce the h out, so we get 4x plus 2h minus 3. And there's our answer. Let's try it again. Step 1, we're going to find f of x plus h. This is kind of a weird one, because if you just plug it in, it's just that. So that's not that hard. Now step 2, we're going to plug it in. This is where it gets pretty intense. So we have x plus h minus the original, which is this thing, the root of x, and dividing by h. Now remember, the goal is to get rid of this and this. So at first glance, it looks like you can't do anything. We're going to use a concept from last chapter, the conjugate. We're going to multiply it by x plus h, the root of that, plus root x over itself. That's pretty wild. And let's see what happens. The top becomes x plus h minus x. And the bottom becomes h multiplied by the root of x plus h plus the root of x. Notice how the x's cancel and the h's cancel by doing that. So there it is. There's our answer. 1 over the root of x plus h plus the root of x. That's a pretty cool one. You just want to make a note with the radicals. You simply use the conjugate. Now, a lot of people think you just use a conjugate for the denominator. So this example is showing that doesn't matter. You can do it for the numerator as well. So if you have any questions, please let me know. Good luck on the homework.